Welcome to my channel. So in this video, I am going to explain the pin diagram of 8086 microprocessor. So in the previous videos, I have explained clearly about the architecture of 8086 microprocessor. So in this video, I am going to explain the pin diagram of 8086 microprocessor. So this pin diagram is divided into two sections. So already I mentioned while explaining in the architecture of 8086 microprocessor. So here the architecture of the 8086 microprocessor will operate at two operating modes. One is minimum mode and maximum mode. Okay. So what is minimum mode actually? So the minimum mode indicates the normal processor execution. So it is a single processor support. So that is normal 8086 processor. It is going to perform the normal the ALU operations, everything. Okay. So it is a single processor mode. That indicates what minimum mode operation. And also this 8086 microprocessor will support for multiprocessor support. What is multiprocessor support? The name itself you can see multiprocessor support. So multiprocessor support means we can interface the additional processor to the main CPU. So here the main CPU is what master, and the other CPUs are what it will act as a slaves. For example, I gave no that there is mathematical for operating of mathematical complex operations. So mathematical complex operations cannot be done by using normal processor, that is a single processor mode. Okay, so for that purpose we need some additional processor. Okay, for example, we can take 8087, that is 8087 is a math coprocessor actually. So it performs the complex exponential and factorial, the type of function complex functionalities can be carried out by using that type of processor. So if you want we want for our design, if you want some complex mathematical functions for our design, so we need to interface the extra processor, that is additional processor to your main CPU. So that can be done by using that is multiprocessor support. Okay, so that's why this 8086 microprocessor will support for both single processor mode and multiprocessor mode. Okay, so that is differentiated by these signals pin number 24 to pin number 31. See here in this diagram, pin number 24 to 31, okay, that 8 pins, that is QS0, QS1, then S0 bar, S1 bar, S2 bar, lock, and RQ/GT1, RQ/GT0, and RD bar. So these pins are mainly used for multiprocessor support when the 8086 operates at multiprocessor support. If the 8086 operates at single processor mode, these pins are what INTA bar. The right hand side. Okay, right hand side just here. So INTA bar, ALE, DEN bar, DT bar, DT/R bar, M/AO bar, and WR bar, and HLDA and hold. These signals are are included. That is, these signals are included while the 8086 microprocessor will act as single processor mode. Okay, so this is the basic difference between the multiprocessor support and single processor. Okay, if the 8086 operates at a single processor mode, these are the signals, that is INTA bar to hold signals will be activated for the particular pins. If the 8086 operates at multiprocessor support, if it is single processor support, INTA bar to hold. If it is a multiprocessor support, that is QS1 to, that is RQ bar/GT0 bars. Okay, so these 8 pins only it is going to change. Remaining all the pins are common when the 8086 is operated at either a single processor support or multiprocessor, that is minimum mode or maximum mode. Okay, now let us see one by one. So what are the different signals are available? Okay, so I'm going to explain clearly. See here, the pin number, already I told in 8086 microprocessor it consists of what 16-bit data bus, because it is a 16-bit processor. It carries the 16-bit data, right? So it performs 16-bit operation. So it consists of what 16-bit data bus and 20-bit address bus, right? So here 16-bit data bus is what AD0 to AD0, that is pin number 16, AD0 to AD14, and also 39 and 38 pin, the 39th pin. Okay, 39th pin, that is AD15 totally. So it is a multiplexer address and data bus. See here, AD0, A indicates address, D indicates data bus. So multiplexer address and data bus. So both address bus is there and data bus is there. Okay, so how to separate that multiplexer address and data means by using ALE signal. By using ALE signal, that ALE signal is what? Pin number 25. So the pin number 25 is what? ALE signal. This ALE signal is used to separate the address bus and data bus. Okay. So if ALE is equal to 0, if ALE is equal to 0, these pins will act as address bus. Okay, it mainly deals with what I mean, it is going to separate. It is going to separate both address bus and data bus. If ALE is equal to 0, it will act as a data bus. If ALE is equal to 1, it will act as a address bus. So that is a very very important concept over here. So it mainly deals with what? ALE signal. If ALE is equal to 0, it will act as a data bus. If ALE is equal to 1, it will act as a address bus. Okay, so sometimes, okay, sometimes in competitive examinations, they are going to ask, okay, this type of questions. Okay, so at what condition if the address bus is activated, at what condition if the data bus is activated. That is, it depends on ALE signal, right? So now this is about what? Pin number 60, that is pin number 2 to pin number 16. Similarly, pin number 39. Okay, these pins are over. Then the supply pins here is pin number 1 and pin number 20 and pin number 40. That is, three pins are what? Supply related pins actually. So here pin number 1 and pin number 20 is ground, and pin number 40 is what? Supply voltage. That is 5 volt plus 5 volt supply. Okay, these three pins are what? Supply to the CPU, right? Next come to this side. That is pin number 17 and 18. Pin number 17 and 18 indicates NMI means non-maskable interrupt and INTR means interrupt request. So these two pins are what? Interrupt related functions. If you want to access the external interrupts, okay, so that interrupt pins will be activated by using NMI and INTR pins. Okay, this is external pins are available for accessing the interrupts. Okay, now pin number 19 is what? Clock signal. Okay, so clock here, the clock signal is, it is used to provide the clock to operate the processor. Okay, so clock is one of the important factor. So that clock signal will be generated given to the CPU is what? In pin number 90, right? So this is about what? Left hand side pins. Then come to the right hand side pins. So here the right hand side pins here, already I have explained what? Pin number 40 and 39, and pin number 38. See here, pin number 38, 37, this one, okay, 35, 36, 37, 38. These pins are what? It will act as both address bus as well as some status signals. Okay, right? So already I told us in the 8086 microprocessor, it consists of what? 16-bit data bus and 20-bit address bus, right? So here 20-bit address bus means what? So here it is multiplexed with address and data bus, that is AD0 to AD15, that is 15. Then 16, 17, 18, 19. Totally 20 pins are there to access the address, right? So that is it can access up to 1 MB of memory location. That can be calculated by using what? 2 power n formula, where n is equal to number of address lines. If 2 power 20 is equal to 1 MB memory locations. Okay, so these pins are will act as what? Address buses, right? In addition to that, some additional functionalities are there. That is S3, S4, S5, and S6. Okay, this can be performed as some status signals. Okay, so I'm going to explain that one. So this S3 and S4 signal. Okay, in case if pin number 38 and 37, 37 and 38 will act as what? Status signals. S3, S4, S5, S6 means, so each status signal has some operations. Okay, so here S3 and S4 gives the status of memory segment. Actually, status of memory segment currently accessed, right? So just remember, S3 and S4 is mainly used for what? Status of memory segment currently accessed, right? So what are the segment registers here? Extra, data segment, port segment, stack segment, and extra segment, right? So if S4 and S3, if S4 the S3, that is, if it is 0 0 means extra segment, if it is 0 1 means stack segment, if it is 1 0 means port segment, if it is 1 1 means data segment. Okay, so these are the very very important. Okay, this S3 and S4 is mainly used to state status of memory segment currently accessed, right? Then S5. Now let's come to the S5. This S5 status signal gives the status of the interrupt enable flag. Okay, so interrupt enable flag updated every clock cycle. Okay, so what is the status of that interrupt enable clock? That can be decided by using this S5, right? Then S6, S6 means if S6 is low, okay, if S6 pin is low, the 8086 controls the shared system bus, because the bus is shared with some other processor, na? So that can be done by using this S6. Okay, if S6 is low, the 8086 controls the shared system bus. Okay, so these are the status signals which are used for in 8086 microprocessor, right? And also the status S7, okay, the status S7 is mainly reserved for further development. Okay, so that status signal is used for further development, further operations, right? Okay, so these are the status pins. Okay, so remember S3 and S4 is used for what? That access status of it is used to find the status of memory segment currently being accessed. And S5 is what? It gives the status of interrupt enable flag. And S6 indicates what? It is used to control the shared system bus. And S7 is used for what? That is further development, reserved for further development. Okay, so these are the functionalities, right? Next, come to the next point. This BHE bar. Here BHE bar is combined with A naught. If BHE bar is combined with A naught, so that is bus I enable actually. So this if you combine with A naught, and it gives the data access. Actually, data lines will be selected by using this one. If BHE and A naught, so if BHE and A naught means, if it is 1 0 means byte will be accessed, that is D naught to D7 will be activated. If it is 0 0 means word will be activated, that is D naught to D15 is activated. If it is 0 1 means again byte will be activated, that is higher order byte, that is D7 to D8 to D15. Okay, D8 to D15 will be accessed. Okay, so based on the BHE bar and A naught combination, it is going to access the, that is lower order lower order bus, and higher order that is a full data bus, and higher order bus. Okay, if it is 0 0 means that is word. Okay, word, that is BHE bar is 0 and A naught is 0 means word of data. That is word of data means what? D naught to D15 totally fully access. Okay, of data bus. If it is 0 1 means what? If it is 1 0, sorry, BHE is 1, BHE bar is 1, and A naught is 0 means byte, that is higher order data bus, D naught, sorry, lower order data bus, D naught to D7 will be activated. If it is BHE bar is 0 and A naught is 1, that is byte, that is higher order byte, higher order data bus, that is D8 to D15 will be accessed. This is the functionality of BHE bar, right? Then MN/MX bar is very, very important. So here the MN/MX bar pin is mainly used for to decide whether the processor is operated at single processor mode or multiprocessor mode. Okay, minimum mode or maximum mode. Here MN indicates minimum mode and MX bar indicates maximum mode. Okay, so this pin number 33 is used to decide whether the processor is activated in minimum mode operation or maximum mode operation. That is single processor mode or multiprocessor mode. If MN/MX bar is equal to 0, if MN/MX bar is equal to 0, 0 means what? MX bar is active, that is maximum mode will be operated, that is multiprocessor support. If MN/MX bar is equal to 1, it will act as a single processor mode. Okay, so this is the operation of MN/MX bar, right? Next, come to the next signal, that is RD bar. This RD bar is mainly used for what? That is reading the data. Okay, reading the data from the memory, or okay, that can be done by reading operation, read the data operations. Okay, memory or IO data, right? Next, come to the now I am going to explain the common pins. Common pins are what? That is reset, ready, and test. Reset, ready, and test pins are mainly used for so actually this test pin is mainly used to use for, it is a dedicated for 8087 coprocessor. Okay, so if you want to access the 8086 87 coprocessor, so this test pin will be active low input, right? And reset and ready. Okay, reset is what? It is mainly used for what? Reset the entire system, entire 8086 microprocessor. And ready means the it is we used to indicate the system status. Okay, whether the system is ready or not. Okay, so that is ready signal, right? So remaining 8 pins I am going to explain. Remaining 8 pins, what? There is either it is the maximum mode operation or minimum mode operation. First let us see the that is maximum mode signals. So here the maximum mode signals is what? QS0 and QS1. First, let us see the QS0 and QS1. So here QS0 and QS1 is what? It is mainly used for Q state, finding the Q status, right? So if it is 00, no operation will be carried out. If it is 01, first byte of opcode will be activated. Then if it is 10 means empty the queue. Queue is empty, and 11 means subsequent byte from queue. So it is used to find the status of what queue. Okay, already I told. So there is, it has six byte instruction queue. That status can be controlled by using this qs not on qs1, right? And s2 bar, s2 s1 s0, this s2 s1 s0 also a status signals. So it performs some different functionalities, right? Already I explained, that is s3 s4 s5 s6 s7. The same thing here, s0 s2 s1 s0. So it is used to perform the different operations. Let us see the one by one. So if s2 s1 s0, if it is 0 0 0, okay, s2 is 0, s1 is 0, s1 s0 is 0. If it is 3 or 0 means the interrupt acknowledge will be activated. That is interrupt acknowledge operation will be carried out. If s2 is equal to 0, s1 is equal to 0, 0, and s0 is equal to 1, read IO port. Okay, if it is 001 means read IO port. If it is 010 means write IO port. That is s2 s1 s0. You just make the combinations. So if 011, that is s2 is 0 and s1 is 1 and s0 is 1 means halt the operation. Then if it is 100, code access. If 101, read memory. If 110, write memory. Okay, 110 means write memory, and 111 means that is a idle state, right? So these are the operations are carried out in maximum mode operation, that is s2 s1 s0. Okay, is used to generate some appropriate control of the operation, that is interrupt acknowledge, read IO port and write IO port, halt, code access, read memory, write memory, and idle state. Okay, these are the three signals, right? Next, here the log signal. Okay, so here the log signal is mainly used for what? It is used to log the, external bus master. Okay, so mainly it is used for log the external bus. So for example, if the bus is accessed by some other resources, okay, that can be locked until the operation is until the operation is completed. Okay, so that can be done by using log signal. And rq not rq slash gt not bar and rq slash gt1 bar means request and grant signal. Okay, so request and grant signal means, so for example, if you want to communicate with our main CPU to other CPUs means we are going to request the system bus. Okay, so I need to operate some operations. Okay, so we have to give the request. Okay, so after request is accessed by the other processor, so some grant signal, so that grant signal will be generated from the other processor to main CPU, right? Or otherwise 8087 processor wants to request the 8086 processor. Okay, my data is completed. Okay, so I am sending the, so it is going to send the request to the main CPU, right? So this CPU, what it will do at current machine cycle, it is going to complete the current machine cycle operation, and it will generate the grant signal to the 8087 processor. I am ready to access the data, like that, right? So after sending the acknowledgement to the 8087 processor, this 8087 processor will access the system bus of your 8086 processor to send the data from 8087 to 8086. Okay, so this is the request and grant signal, that is mutual understanding between the two processor. Okay, the best example is what? Mutual understanding. Okay, so I am ready for to give the data, so I just give the, so requesting, accessing, request and grant signal, right? So these are the 8 pins which is mainly used during the 8086 operates at maximum mode operation. Now let's come to the minimum mode operation. Here the minimum mode operation is what? So here hold and HLD is mainly used for what? DMA access. Okay, so DMA control signals. So if you want to access the direct memory access, so you can access the hold and HLDA signals. And WR bar signal is mainly used for what? Writing operation. Okay, data writing operation. M slash IO bar indicates here memory and IO bar. If you want to access the memory, so this memory will be activated. If you want to access the IO devices, that's IO bar is activated, right? right? So that is here both memory and IO access, that is decided by the M slash IO bar signal. And DT slash R bar means it is used to control the direction of data flow through the transceiver. Okay, so here it is mainly used to control the direction of the data flow. So direction of the data flow through the transceiver. Okay, so that is transmit and receive. Okay, transmit and receive data, transmit and receive, and options will be carried out by using dt slash r bar. Okay, so and den means data enabled, so that is enabling the data signals, right? And ALE already I explained. Okay, so it is mainly used to separate the multiplexer address and data bus. If AL is equal to 0, it will act as a data bus, and if AL is equal to 1, it will act as a um, uh, if AL is equal to 0, it will act as a data bus. If AL is equal to 1, it will act as a address bus. That is the operation. Then INTA bar means that is interrupt acknowledge actually. So it is going to give the interrupt acknowledge. Okay. So interrupt is over, or interrupt is accepted. So that type of acknowledge will be carried out by using INTA bar. Okay. So these are the basic operation. Okay, operation and basic signals which are available in your 8086 microprocessor. Okay, the main thing is what? So this 8086 microprocessor is mainly it is going to operate in both minimum mode operation, that is single processor mode, and maximum mode operation, that is multiprocessor mode. So only the 8 signal pin number 24 to pin number 31, that 8 signals will be separated, that is 8 signals will be changed. Okay, so during the single processor mode, on single processor mode means some signals, and multiprocessor mode means some signals. Okay, remaining all 32 pins are common when the 8086 microprocessor either it operates at single processor mode or multiprocessor mode. Okay, so hope you understood and enjoy this video. So please like, share and subscribe this video. Thank you.